Well, good afternoon, everyone. Good afternoon. We are thankful that you are here. And for some who may be watching in a different time zone than the East Coast time zone, good evening, good afternoon, good morning. And actually over here in the East Coast is evening. So hello, everybody. We're elephant happy and peacock proud that you are with us today. I am the Reverend Vernon K. Walker, and I so happen to be the Senior Program Manager at Communities Responding to Extreme Weather, which is the organization that is sponsoring this event and that has brought a host of events throughout this week. And we have lots more events happening in the coming days. This is our fourth Central Climate Prep Week event. This is our fourth one. And if you missed the previous three, you certainly missed a treat. But those will be up on YouTube, and we will be sharing that video with those that registered for this program. So you will have when it's all set and ready, you will have an opportunity to view those, but you are certainly in for a treat tonight. Oh, it's going to be a wild journey into the ocean. And it is going to be interesting, exciting, compelling, dynamic, all rolled in one, because we are so glad we have a dynamic presence with us here tonight. But before I get into introducing the esteemed Dr. Hartmann, we want to acknowledge that Climate Prep Week could not have been done without our many, many partners. And for those that don't know, this is our fourth year hosting a Climate Prep Week. We started in 2018. And we have been rolling ever since, even in the midst of a pandemic, even though we would love to be with you all in person, but because we're still in a pandemic and the Delta variant is rising, we're thankful to use technological means that we have available to be able to interact with you all. I am going to show a slide here to thank all of our partners, and so that you can see in Facebook land and virtual land, so you can see some of the partners that we've been working with. And again, it wouldn't have been possible without them. So here are the many folks that we've been working with. Special thanks to the Library Association, the Blue Marble Librarians, the Massachusetts Library System, Michelle Eberly, and the terrific work that she's doing over there. And there's so many partners, and time would not allow for me to thank each and every partner, because I wouldn't want to leave anyone out and make anyone mad. So I just want to give a general thank you to all, and we're looking forward to continuing our relationship beyond Climate Prep Week, because we know that extreme weather will continue to happen beyond September. So really many thanks to the wonderful, extraordinary partners that we've been working with for this year's Climate Prep Week. And we're so ever grateful. I want to thank the team at Crew, Allie and Colin, who have been extraordinarily wonderful and helpful in pulling this together. I want to thank the team that we had in the summer, that also helped to jumpstart and kick us off in this planning process. Margaret and Layla and so many others. So we just want to thank you all. And we're again so glad and so ever grateful for our many wonderful, astonishing partners that we've had in this work. And we are just grateful, because we believe that in our collective solidarity, preparedness can happen. And we believe that the best way to become climate resilient is through social resilience. And the way to build up social resilience in a community is people connecting with each other across different walks of life and spaces and places. So we're so thankful for the many partners that we've been able to work with. Well, you are in for a treat tonight. You are in for a doozy tonight. If you don't know, you better ask somebody. But that's all right. You're here, and we're so glad about it. We are extraordinarily blessed and delighted to welcome Dr. Hartmann, Dr. Aaron Hartmann, who has been just a wonderful individual. And for many, for some who don't know Dr. Hartmann, I want to introduce to some and present to others Dr. Aaron Hartmann, who was a marine biologist and conservation ecologist working to reverse the decline of coastal ecosystems, particularly coral reefs. He focuses on solutions that duly benefit humans and the environment. He received his PhD in marine biology from Scripps Institute of Oceanography and was a postdoctoral researcher at the Smithsonian National Museum of Natural History before joining Harvard University as a research associate in orgasmatic, you might need to correct me on that, but orgasmatic and evolution biography. So again, biology rather. So again, presenting to others and introducing presenting to some and introducing to others the wonderful esteemed Dr. Aaron Hartmann. And without further ado, I'm going to step off of spotlight and we're going to turn it over to you, Doctor, and the floor is yours.
Well, thank you very much for that wonderful introduction, Reverend Walker. I appreciate it, and I will hope to live up to your wonderful and kind words. I really appreciate it, and I'm excited to be here to speak with all of you tonight. This is a really excellent organization and excellent series of talks. I'm disappointed I haven't been able to make it to any yet. I'm happy to be able to host one today to speak with all of you. I saw the comment in the chat from Jenny about making dinner for kids. My own children, 1 and 4, are in the next room over eating their own dinner right now. And we may hear them at some point, and I wouldn't rule out completely that we might see them at some point, but we shall see. As Reverend Walker described in my intro, I am a marine biologist by training. I study coral reefs in particular, and I'm currently now a research associate at Harvard. It's in organismic and evolutionary biology, or OEB, and I teach marine biology and conservation biology. So I really think about kind of the natural science side and what we think of as pure fundamental science, as well as how that relates to conserving the ecosystems and conserving the natural resources of our planet. And particularly in the oceans, and most particularly for me on coral reefs. And so I'm excited to talk with all of you today. I'm going to talk a little bit about the oceans generally, but I'm going to focus on coral reefs and some of the work that I'm doing. I will likely ask you questions as we go along, because I probably will go into teacher mode as we go. Feel free to use the chat to answer those questions. Feel free to also throw questions into the chat. I might stop as we're going and answer them, or I might also just leave them to the end, because we will have some Q&A time, but don't hesitate to throw those in there. Colin is also going to help me sort of aggregate all of those questions and whatnot, but sometimes I'll hop off in the middle depending on how we're doing. So I will share my screen here, and I'm going to show you some slides purely for the purposes of just giving you some visuals, because I think when we're talking about the natural environment and ecosystems, words can describe them quite beautifully, but I think showing them in pictures goes even further. And so I'm going to talk today primarily about climate change and coral reefs, which is my area of expertise. So what we're looking at here is a coral reef in the Pacific. Coral reefs are aesthetically beautiful ecosystems. You can just tell from looking at them that they're extremely biodiverse. They have a lot of different species living on them. They are the most biodiverse ecosystem in the ocean and arguably on the entire planet. There's sort of an ongoing debate between coral reef ecologists and rainforest ecologists about which has the most biodiversity. It's not really in my mind, an important debate, but it's one that's out there. And being that they're in the tropics, and as you can see from this picture and other images you might have seen of coral reefs or from experiencing them in person, they tend to live in very, very clear water, which exists in the tropics. And that's important when we're thinking about corals and how they operate, which I'll get into in a little bit more detail. But while we're still thinking about the entire ecosystem of coral reefs, as I mentioned, they're extremely biodiverse. So they only cover about 0.1% of the surface of the ocean, which is a very small amount, right? But they're home to about 25% of the species that live in the ocean. And it's estimated that about 50% of species in the ocean live on a coral reef at some point in their life. And what we mean by that is they might live on a coral reef when they're very young, and then they migrate off and they swim through the ocean for the rest of their life. Or they might move to a coral reef occasionally to feed. So we think about 50% of the species in the ocean are on a coral reef at some point in their life, which is really staggering when you think about how little of the ocean they actually take up. In addition to being beautiful, coral reefs also provide what we call ecosystem services. So these are things that are beneficial to humans. The list is pretty long, but just to highlight a few, we think about things like shoreline protection. So they're natural break walls to reduce storms, hurricane level storms, or just kind of quote unquote more normal wave action. They're sources of food for about 1 billion people on Earth. And these people tend to be those who are the most food insecure, tend to be those the most food insecure on the planet. And coral reefs are also the source of a lot of important medicines. So when we're talking about medicines, we're thinking about certain molecules that are produced by organisms on coral reefs. And I often, when I talk to people about coral reefs, I often say, you know, if you might not know what your connection is. You might say, I've never been to a coral reef. I don't like to go in the ocean. I don't have any interest in snorkeling. So, you know, what does coral reefs really have to do with me? And one that directly relates, I think, to most people is this idea of finding medicines on coral reefs. And as an example of that, there is a sponge species. So a sponge is sort of the most basic. Think about like a loofah. But a sponge is kind of like the most basic, and we think one of the most ancient forms of life, at least multicellular life on Earth. And there's a sponge that lives in the Caribbean. It lives in about a foot of water. In textbooks, it's described as a drab Caribbean sponge, which should give you a sense of what it looks like. It is dark brown, and it likes to cover itself in sediment. So it basically likes to be covered in sand all the time. So it's basically kind of as boring as you might get for a coral reef organism. This sponge in the 50s was discovered to produce a certain type of molecule not found elsewhere, but that is very good at fighting viruses. So this molecule went on, this class of molecules went on to be used to create the first drugs that we had that effectively fought HIV. They've been used to create drugs that fight Ebola. And they're also the source of remdesivir, which you may remember from earlier in the pandemic, showed some efficacy against SARS-CoV-2 or COVID-19, the virus that causes COVID-19. And so here from one sponge species on that's considered pretty boring, and you might kind of literally walk over as you go into snorkel on a Caribbean reef. And we found all of these drugs that are fighting pandemics ranging from HIV to COVID-19. And so that sort of gives you a sense of how coral reefs can hit home. And the reason for this, part of the reason for this, that the coral reefs have these amazing molecules on them is these organisms are extremely old. Modern reefs are about 200 million years, and there's so many species on them, right? So these species are all fighting one another. And when you're having to fight off tons of different viruses and tons of different bacteria and all sorts of other organisms that are maybe your size, you evolve through time some really good defensive mechanisms. And so that's partially why we think that we find these incredible molecules that do incredible things in medicine for humans. And so in addition, tourism revenue and just our general enjoyment is another ecosystem service that we get from coral reefs. As many of you may be aware, coral reefs are declining worldwide. They're declining due to things that we call more like local impacts. In other words, are things that are happening locally, such as eutrophication, which is the runoff of pollution, particularly nutrients like fertilizer, sewage, or other forms of nutrients, as well as overfishing, so taking off too many fish. And the problem with this is it sort of breaks the filter. A lot of fish on coral reefs are herbivores. So you can think of them like lawnmowers, and they're going around eating algae that live on the seafloor. And these algae, like, you know, grass in your yard or grass and things, dandelions growing up between on the sidewalk, are things that compete with corals. And so anything that competes with corals is going to be not so great for the reef, because corals are forming the foundation of the entire reef. So when we remove things like too many fish that are herbivores, it can also have negative impacts for the reef. And then finally is global change and a phenomenon called bleaching that you see here in this picture that I'll talk a little bit in more detail about in a moment. One particularly cool thing I think about corals and coral reefs is that they are the only animal that builds structures that are observable from space. Does anyone have a guess as to what this is? What's in this image? You can put it into the chat. No takers? Great Barrier Reef, exactly, Colin, yep. So this is off the coast of Australia. This is a Great Barrier Reef. And so what you're actually seeing are reef formations or reef structures that are built primarily by corals. And if we're thinking about corals building reefs, what does anyone know what we're actually talking about? So how does a coral build itself? What does it build itself out of? Similar to us, I'll give you a tip. So what we're looking at here, what corals build, is skeletons. It may have seemed so obvious that it was a bit of a trick question, but corals build skeletons made of calcium carbonate. And one beauty in this is that to do that, they're taking CO2 out of the water. So this is another ecosystem service of coral reefs, is that they are actually drawing down CO2 and locking it up in their skeletons and in rock. And in doing so, they can build barrier reefs, they can build entire islands out of skeletal material as they build up on top of each other. Some die below and they continue to build up. So it's pretty incredible what these animals can do and what these animals can build. Okay, so what are these animals exactly? So they're a cnidarian, which means that they're related to jellyfish and sea anemones, like this picture on the far left. But the reason, so I mentioned earlier that corals in tropics live in this very clear water, right? And so clear water means the water doesn't have a lot of food in it for things that are taking food out of the water. So what do corals do? Well, corals form a symbiosis or a mutualism with single-celled algae that live in their tissues. So these algae are not like the algae that I talked about competing with corals on the seafloor of the ocean. Those algae you can think of as like plants in the garden. But the algae that are living in corals are actually single cells and they're quite small. So we're seeing in this middle picture here, this is zoomed way in. And so those brown dots are the algae. And so what these algae, these symbiotic algae do is they're photosynthesizing, producing sugars, producing fats, and they're releasing it to the coral. And that can provide anywhere from 75% to 100% of the energy that the coral needs to survive. And so even though the coral can eat and does eat food from the seawater, it really doesn't need that food very much because similar to a plant, it's using photosynthesis of the algae to feed itself. You can think of it like it's farming the algae in its tissue. And in exchange, the algae are getting protection from predators. And so the algae are happy living in the coral, and they're also getting the nutrients that they need to do photosynthesis. And then finally, the other component, and I kind of think about corals as on the left, that they're an animal overall. In the middle, they act like a plant. On the far left, they're kind of like a rock because they're building this skeleton and putting down the skeleton that's building all of the reef structure. Okay, so the symbiosis that the corals form with single-celled algae also becomes their Achilles heel when we think about climate change. And the reason for that is that when temperatures warm, the mutualism or the symbiosis between the coral and the algae break down. And so photosynthesis in the algae starts to break down, and they start to produce something called reactive oxygen species. I know it sounds like a very technical term, and it is, and I won't get too deeply into it, but what it does essentially is it hurts the coral. And so what that does is then triggers an immune response in the coral to either consume or kick out those algae that are hurting them. And in the same way, actually, that if you exercise a bunch and the muscles start to hurt, that's because you have reactive oxygen species building up in your muscles. But when you have a coral and it's a much smaller organism as an individual, what it's actually doing is going to expel all those algae in response. But of course, it's now expelled its primary food source. So it's in trouble. And so basically, if the temperatures don't reduce down significantly enough for it to then reclaim its algae and form this happy relationship again with its algae, then the coral will essentially starve to death and die. And so as you can imagine, if you have an episode of time where the water gets too warm and a bunch of corals bleach in one location, and the temperatures don't stabilize or decrease enough in, say, the days or weeks after that, you can get a lot of coral mortality as a result of that. And so mass bleaching of corals can lead to mass death. And I should make a distinction there in that when a coral first bleaches, it's not dead. It might look white like this because it's lost all its symbiotic algae, but it's not yet dead. It's going to be feeding off of its stored up energy in the same way that we do. But in the same way that we do, if we go through that and no longer have energy sources, then we won't survive, and just like the coral won't survive. And so in this way, mass bleaching can lead to mass coral death over time. And due to this phenomenon, plus the local impacts that I mentioned earlier, we've lost upwards of 50% or more of coral reefs on the planet. And there are major concerns that coral reefs might be the first ecosystem that's succumbing to global climate change through time. It sounds dire, and we are not there yet. So I don't mean to scare you necessarily, but this ecosystem seems to be particularly sensitive to warming. And that all relates to the fact that these coral animals, which form the entire foundation, the entire base of this entire ecosystem, are sensitive to temperature increases because it causes the breakdown of the symbiosis that they form. And so that's a really important point. And so before I move to that next slide, just to point out too, that because corals are the base of this ecosystem, you can imagine they're kind of like trees. And if you take the trees away, everything else that lives in the forest suffers, right? So in the same way that if you take all the corals away, everything else that lives on the reef suffers. And so you lose the entire ecosystem, or most of the ecosystem, or the ecosystem changes to a drastically different ecosystem dominated by many fewer species. Once you lose the corals, then you lose a coral reef. And so as a result of that, we lose all of this diversity, as well as all these ecosystem services or these benefits that we get from having coral reefs, such as food and medicine and tourism dollars. And so it can be particularly harmful to human populations that are dependent on coral reefs on a daily basis. And it can be particularly harmful to those who are not, because we're losing things like valuable molecules that we haven't even discovered yet that will be able to help us cure the next disease or to cure certain cancers. And so, again, that's sort of a loss that relates to one type of animal that just has these massive ripple effects for many other species, including humans. as a result of climate change, but also as a result of more direct kind of local human activities. And so from there, I'm actually going to transition in a moment to talking a bit more about a case study of some of the work that I do. But I'll just touch really briefly on some other negative impacts that climate change is having on the oceans, very briefly and not comprehensively. But of course, the oceans are warming slightly through time due to warming of the atmosphere that's being transferred into the ocean. As a result of that, you get both melting of ice and you also get thermal expansion. And so the water is actually, when you combine those two things, the water getting sort of larger and bulkier, you get higher sea levels. Sea level inundation is something that I think is something that maybe most people didn't think about 5 years ago, but certainly are now, with scenes from that we've seen from Louisiana for over a decade now, but also scenes that we're seeing in places we're not used to seeing them, such as New York City and most recently. And so you have that effect going on. But in terms of the organisms themselves, you have things getting thrown off, like when we may have seasonal booms in, say, phytoplankton that feed an entire food web, or certain fishes, small fish species that feed on those phytoplankton that then feed an entire food web. And so as a result of that, you have food webs that are being completely thrown off in timing and also in abundance of the things at the bottom that are feeding everything else. And as a result of that, you may have major declines, say, in large fish that humans like to eat, or even all the way up to having impacts on even larger predators. Another impact that we often think about alongside warming is that of ocean acidification. So that is, as more CO2 goes into the atmosphere, more goes into the ocean, and more CO2 in the ocean is actually decreasing the pH. So it's making it, it's still a basic in that it's over 7, but it's making it more acidic. And so that makes it more difficult for things that produce calcium carbonate skeletons, such as corals, to make their skeletons. And so it's requiring more energy. And of course, we fear that down the line, it might actually cause some dissolution, and also it already seems to be causing weakening of skeletal structures, which, as you can imagine, are bad for the organisms that are producing those structures. And then finally, as on land, warmer temperatures create conditions that are better for things like parasites and diseases. And so we don't have great evidence yet, but it's thought that some of the increased instances of diseases on things like corals, for example, that we're seeing in places like the Caribbean may be related to warmer waters, because these parasites and these microbes that cause diseases are happier in these warmer waters. Okay, so I'm going to switch to a case study. Colin, how am I doing on time? Any sense of how long I've been going for?
You're still fine for time. You have, I would say you got 10 minutes, okay. So don't worry too much.
Wonderful. Okay, so transitioning now into a bit of a case study on some of the work, some work that I'm just getting going recently with a major collaborative team, relates to the area of Southwest Madagascar. In particular, one of the and linguistic groups of Madagascar, which encompass the Viso fishers. And so Viso literally, I believe, means people who fish. And so these are people who are extremely, this is an indigenous group who's extremely dependent on fisheries and fishing for livelihoods and for food. And they fish primarily on coral reefs using the boats that you see here in this image. And so this group is one that we're working with extensively. And this region more generally is, has extreme concerns related to food security at the moment. And so I mentioned that these people have traditionally fished reefs, and it's worth pointing out that many more people have been turning to reefs as a source of food. And a major reason for that is that droughts, on top of what are already arid conditions sort of normally in this region, are making it harder and harder to farm. So agriculture was already difficult, and then prolonged drought has made it even more difficult. Is leading to more pressure on coral reefs in terms of being a source of food, is also leading to migration. So think of them like climate migrations of people moving to the coasts because they can no longer farm inland and trying to find food sources along the coasts. And a little bit south of where we work is reaching famine levels, as was recently described by people at the UN, basically saying this is one of the first sort of climate-induced instances of famine that we've observed, though of course we expect more of these to happen in the years to come. And so all of this amounts to a lot of increased pressure on coral reefs. And so the coral reefs there are already what we would call overfished. In other words, more fish are being caught on them than the ecosystem can replenish through time. And because of that, people end up mostly catching juveniles, so very, very small fish that aren't able to grow to maturity to then reproduce, which, as you can imagine, makes it even harder for more and more fish to grow, but it's all that is left there and all that they're able to catch. And so with more and more people moving to this area to try to catch them, of course, it's compounding this issue. And then you add on the fact that in addition to this overfishing that's happening, you also have things like climate change and bleaching and other more local impacts that are negatively impacting the reefs. And so in recent years, a fisheries management organization has been formed as a collaboration between the local fishing villages, the fishers themselves, and facilitated by some NGOs in the country. And these local fishers decided that their strategy that they wanted to use to help rebuild their fisheries was to create more fish habitat by using something called artificial reefs, or reefs that are built out of some sort of material that we put into the ocean, such as limestone blocks or concrete boulders or things like that. This decision was sort of as opposed to something like doing what we think of as like a crop rotation on land, of closing down certain reefs to fishing to allow them to replenish and moving to another. But I think it's a completely sound and understandable decision to make, given that they are so dependent on these reefs and they are so food insecure. It's hard to imagine closing down one of those food resources to wait a few years for it to replenish when they may not have those years to wait. And so this was a community decision that was made. And so what they did in coordination with Rev Dr, the NGO that I mentioned earlier, is that they built some small artificial reefs to start. And so what they found is that to some extent, they do see fish on these artificial reefs. And so it's encouraging that potentially this would be a way to help stimulate their fisheries and bring back some of their food resources. But what we don't know is whether by building these sorts of artificial reefs, whether we're just aggregating fish that are already there, making it easier to catch them, which can then compound the overfishing issue, or whether it's actually stimulating the growth of new baby fish by giving habitat that baby fish like to live on. Now, all of a sudden, more of them survive, more of them can hide from predators, and you have more of them available to catch. So we don't really have an answer to that. And we also have a sense that we need to build much, much bigger reefs to get even more impact and sort of even more fisheries benefit in the region. And so that's kind of where we came in. So before I move to that, so our project is basically continuing on this work. Our project is a collaboration between a couple of us at Harvard, a collaborator in Sweden, numerous collaborators in France, and then a massive and incredible team in Madagascar at the local university that's local to the bay that we work in, which is the only marine science institute in the entire country at the University, of Tuliar, as well as working with local community members and some incredible Malagasy PhD students who are working there. But as a team, we are building reefs and building them larger than what you see here, using some technology I'll describe in a minute, to try to stimulate reef growth more quickly, but then also monitoring what that means in terms of fisheries and the availability of fish to catch for food, and then also what that means for the health and the livelihoods of the communities, to really ask this question of, can we rebuild the coral reef? And then what does that look like from, say, like an ecological perspective? And then does doing that actually, just building the reef and building habitat actually lead to more fish available to catch? And then are those fish creating benefits for humans and villages who made the decision to build more reefs? And so that's kind of the general idea. One of the things that approaches that we're taking is we're using these units, which are called ARMS, or autonomous reef monitoring structures. And it started as a tool that we could put out on a reef, leave it for a year or two, bring it back into the lab, and it would look something like it does on the right, and then use it as a tool to census all the biodiversity that's there. So basically see what are all the marine organisms that are living there. You know, we can put them out anywhere. It's a standard amount of space for things to live on, and therefore we can compare one location to the other, the Bahamas to Curacao to Puerto Rico or something like that, to say how much life is living there. What we found is that we got representatives of a massive amount of coral reef diversity, like 75% of the things that we know of that live on reefs, we could find on these arms, which tells you that these arms are good at catching things, quote unquote catching things. It's passive, things land on them and live, but also that a lot of things are really small. But what's really cool about that is we then said, oh, well, what if we took these units and then used them to seed or to pollinate an artificial structure, which when it starts is lifeless, right? So what if we could use this to put marine life on? If we could say, put this out in a really healthy coral reef, all the organisms that make up the healthy reef could land on them, and then we could move it to this artificial structure. Hopefully it would then, the life on it would move off and then grow and help to grow up a coral reef that would then grow into a healthy reef. And so that's kind of the general idea behind this. We're employing a couple of other technologies that are also helping to funnel life to these structures. But basically, as I just described, you put out these arms on a healthy reef, leave them for a year or two, divers go out and collect them, and then move them and anchor them to these artificial reefs or these lifeless structures that we've built. And so here are some nice artistic renditions on the left of sort of what it would look like initially, which is just boulders, and then we put these arms on them. And then on the right is what you might see after a couple of years, which is that things have now grown off. And so you see more things living on the reef, and you see more fish growing over the reefs. But sort of an important thing to point out and kind of relevant to our discussion here is that climate change still looms very large, right? So part of the reason the reefs there have died is because of bleaching and because of warmer temperatures. And so, of course, that isn't really going away. And so we are thinking quite a bit about, you know, how do we build more resilient reefs? And so one of the ways is identifying reefs in the region that seem to be more resistant to bleaching and seem to be able to do better in warmer temperatures. And so we're seeding these arms on those reefs as a way to try to get some of the toughest organisms to climate change that we possibly can. But this is only one approach, and I don't think sort of it's like a overarching and long-term strategy. But it does seem to be one way that we can go out and get organisms that are going to be more resilient to climate change. And we're also thinking about sort of other approaches that we could take, such as reducing the impact of these local impacts, such as overfishing or nutrient runoff, right? But I think it's interesting to think about, and I think about an analogy to cruise work, which is to use, to buy AC units for helping people to get through some of the most extreme heat waves, right? And so that, of course, uses energy, and we want to reduce energy use, but we also need to have strategies that are dealing with the most sort of grave and largest impacts right now. And so with things like what we're doing with these artificial reefs, we hope that they can provide us a way to, at least to some extent, stimulate fisheries, to bring back reefs and to help people survive in the short term. So I'm going to sign off in just a moment and open up for a Q&A, but I gave you sort of a lot of doom and gloom, perhaps, which is unfortunately common with people talking about coral reefs. But I do hope that I have given you some hope to think about, ways that we may be able to help coral reefs. And if we sort of expand out and think about it a little more broadly, I can give you some good news, which is that we have found that minimizing what we call these local impacts, like runoff of pollution, runoff of fertilizer, overfishing of reefs, can actually help to make coral reefs more resilient to things like bleaching and more able to bounce back after they've gone through some traumatic event. And so I think that does give local communities some power to think, okay, if we can reduce something like runoff of fertilizer from a golf course or clean up, a sewage treatment plant that's dumping into the ocean, it can actually have larger scale impacts for helping out the ecosystem. Another piece of good news is there's a lot of people working on helping coral reefs. And if you're looking for something that you can do, anything that we can do to support reduction in greenhouse gas emissions is obviously something that we should push for, ranging from your personal choices on a day-to-day to voting for climate, right? Voting in people who care about climate, and also supporting companies. Companies in the private sector is really taking a large step into helping with climate change issues. And so supporting those companies and sort of knowing who you're supporting when you're buying them, I think is really important. And just sort of using your power as an individual to push wherever you can to do what we can to reduce greenhouse gas emissions and reduce climate change. So I'll stop there, and I'm happy to take any questions.
You can pick questions in the chat, or you could raise your hand or let us know you'd like to be called on in the chat, and we'll be happy to have you ask your question. And as people are generating questions, we will also come back to Q&A as we're going to present a little bit about what a changing climate means for Homo sapiens, which is us, human beings. But we want to give a few minutes to see if anyone has any questions. One question that came up that someone thought of is, how are people helping to protect reefs or helping them recover? If there's a way for the average person to get involved, or is there a way for the average person to get involved or to help out with this work?
Yeah, it's a really great question. So yes, there are organizations and, in academia, like where I am, but also nonprofits that are doing a lot of work in the space, particularly nonprofits. Sometimes they literally will take volunteers who can come help them in the field. But also, like I said, thinking about supporting these organizations that are doing this sort of work and voting, what I kind of call like voting the climate, right? Selecting politicians less based on party and more based on how much emphasis they might put on reducing climate change is something that we can do, especially for people who don't live next to a coral reef, don't have sort of the means or the time or opportunity to go to them or, volunteer to do this work. I think supporting them is a good one. Supporting them financially can be a good one. Another one too, that I think relates more to other ecosystems in the ocean, not necessarily to coral reefs as much, is thinking about where your seafood is coming from and how it's fished. So things like the Monterey Bay Aquarium provide guidance on sustainably harvested fish, when you're going to the supermarket to buy fish and other seafood, supporting that. Supporting local organization or local fishers, I think, is really valuable, and also thinking about not going for the top predators, but instead going for things lower on the food chain, mussels, oysters, things like that can be beneficial. And the reason, just to sort of clarify, the reason why I talked about coral reef fisheries is in part because those fisheries don't necessarily aren't, we for the most part don't want to be eating fish off of them, but it does get a little bit complicated, and we're thinking about livelihoods. And so I am sometimes hesitant to say, don't ever eat reef fish due to some of the sort of dire circumstances that people are in who are fishing for reef fish, such as those who I described in Madagascar. That being said, it's very unlikely, actually not likely at all, that we would ever have access to anything here in Boston, for example, anything caught in Madagascar. But I think in general, thinking about where your seafood comes from is important.
Thank you for that. We have a question in the chat that I can ask from Wendy. The question is, could you talk a little bit about how excess heat is held in the ocean and the impacts of its eventual release?
Sure. Yeah, thank you for that question, Wendy. So generally, it's mostly just going in and not so much coming out. But what happens, so you have a twofold thing going on, which is that you have thermal expansion, which is just literally the molecules, the space between them expanding slightly and getting bigger, and then increasing the level of the ocean. And then you also have warmer water melting ice, which of course, most I'm sure have heard of melting of ice caps and things like that. And so that's just adding more water to the ocean, which is then increasing it. But in terms of thinking about some of the other impacts that it has, some of the concerns too are about warmer water can lead to more stratified water. So that is, there isn't so much mixing top to bottom, which can have negative effects for things that live near the surface and need to get nutrients. There's also some concern about, so there's what we call sort of the global conveyor belt, which is that there's currents that run along the surface of the ocean, but also run along the very deep ocean, and they move, they're very big currents, and they're moving water throughout the oceans of the world. And they are really important for moving heat around. So for example, the Gulf Stream, moving warm water up the east coast of the United States, right? Most of these states would be, including Boston, would be significantly colder without that warm water making its way up. Similarly, cooler temperatures in certain areas along California are because you have cold water moving down the coast of California. And so it has the temperature, and the temperature of the ocean and how the water moves through the ocean has significant ramifications for the temperature on land. And so you can imagine if that gets thrown off due to changing temperatures, that can have all kinds of cascading effects on land, not just in terms of thinking about like our comfort, but also thinking about our agricultural systems, right? So that's another one. One thing I sometimes mention in my class is the movie The Day After Tomorrow, which talks of probably one of the few blockbusters out there that talks about the global conveyor belt. But that isn't going to happen in the sense that the global conveyor belt won't stop overnight. But the science they talk about is founded in reality, this notion that the oceans are moving water and moving heat throughout the planet, and without them, and climate change throwing them off or reducing them can have major implications for temperature on land.
I saw someone in the chat ask a question about where we can go to find that information about like what fish is sustainable. If I can expand on that a little bit as well, I'm curious about if you have any advice for people who are concerned about eating fish sustainably, about how to find information on how to make that responsible choices, sustainable choices about the seafood you're eating that comes from the ocean. So if you have any advice on that or where to find that kind of information, that'd be really interesting.
Yeah, I'm looking distracted because I'm looking up a link. So this is what I mentioned. The Monterey Bay Aquarium runs this program called Seafood Watch. And they make recommendations about sustainable, and they make it relatively easy to follow. When you're thinking about like, are there general sort of like rules to follow, so to speak? Like I said, things that tend to be lower on the food web, such as like oysters or scallops or mussels or smaller fishes, tend to be more sustainable. I also think, you know, especially living in Massachusetts, where I am, where many of us are, we have such a rich fishery. It doesn't mean it's not overfished. I mean, the cod fishing industry has been shut down because of overfishing. But fishing locally is beneficial, both in that we have relatively strict, currently we have relatively strict rules about fishing and monitoring to make sure fishers aren't overfishing. And so you can think about that from a sustainability perspective in the ocean. You can also think about if your food isn't being shipped from Chile, but it's being shipped from, 20 miles north of you, that also is great in terms of greenhouse gas emissions, right? So if your food isn't having to move around quite so much, there's less greenhouse gas going into the air. And so I think that's another good plug for local seafood consumption.
Thank you. We have another question here. Jenny, could you let us know if you would like to ask this question out loud? If you can't, then we can, I can ask it for you, but could you let us know if you could ask that important question that you posed in the chat?
Yeah, I can do that. Thank you so much for your talk. I often think about tourism and our lifestyle in general for us in the richer part of the world, while as many in this richer part of the world really are very poor. But and how lifestyle changes, can be legislated, and in the example of tourism that you were saying, how that is important to the communities that you describe, but they are also destructive. So just wanted to hear if you have any thoughts on that. Ecotourism or such ways to work around this. Thank you.
Absolutely. Yeah, thank you, Jenny. That's a great question. Yeah, so tourism is sort of tricky. I think tourism is really important for connecting people to ecosystems they might not otherwise see, and then sort of making them care, so to speak. I think it's important for people to see these places and then care about them, especially when it's under the ocean, because it's very easy to go to a beach and not have any idea what's underneath. There are, of course, tourism can lead to pretty destructive things, such as building of hotels on fragile habitats and then runoff, right? Like I kept mentioning these local impacts of runoff. A lot of them tie back to sort of overdevelopment on the coasts, and they tie back to things like putting in golf courses that then run off fertilizer. So it can be very harmful, which is sort of what I interpreted you're alluding to. And so there's definitely major problems and major concerns there. I would guess I would call them sort of like zoning concerns related to tourism and the impacts, negative impacts that it has. I guess I don't have necessarily, like, I think ecotourism is a wonderful concept. I don't have enough experience with it to sort of say like how beneficial it can be, though I've certainly seen a number of programs that seem really great, especially when compared to sort of like an alternative that might just be going to a massive hotel on the beach somewhere. But also too, another thing to remember, like another wrinkle and another piece of nuance in all of this is in the Madagascar example, for example, where I work, with COVID, all of the hotels shut down. And when the hotels shut down, the restaurants shut down. And when the restaurants shut down, the buyer of the most valuable fishes was gone entirely. So we fell out of the local fishing market. And so the fishers there in Madagascar were no longer able to sell those fish, and they were already barely getting by. And so now all of a sudden they have nowhere to sell these fish. And so that's kind of an example of it's unfortunate, I guess, that the market is that vulnerable and that fragile for them. And part of our work actually is expanding to think about how to make their markets for fish stronger and more resilient, but also to remembering, I think, that tourism dollars, regardless of whether someone's at an eco resort or coming in to, stay at a hotel, is infusing money into the local economy, which has a lot of benefits, but also can certainly lead to overfishing of reefs, which is a concern. And so I'm almost like rolling my eyes as I say that, just because I feel like I've given you the most wishy-washy kind of nuanced back and forth answer, but these are all things that I think about in the tourism space. And so I guess it's all to say that I don't think the answer is to stop traveling to coral reefs. But I think the answer definitely is that we need to evaluate the way that tourism happens and think about ways to do it that are more gentle, but also are sort of maintaining things like local markets for impoverished peoples who are dependent on those tourism dollars and tourism markets for their livelihoods.
Thank you so much for that insightful response. Thank you so much for the question, Jenny. We have another question, and these are great questions, folks. I'd like to call on Valerie Nelson. Valerie, if you could verbally ask your question.
Sure, yeah, thank you. So obviously everyone is aware about the huge push for offshore wind renewable energy, but I was interested in your thoughts about whether enough attention has been put to the ecological impacts of these turbines and also the cables. More information is surfacing around impacts on right whales and fishing habitat and all that. So is that something that you have spent any time looking at or think is important to study? What the impacts on the oceans will be from these wind turbines that are going to be almost everywhere at this point?
Sure, yeah, thanks for your question, Valerie. I have not, and this is very, very far out of my area of expertise. And so I won't sort of enter an opinion because I guess I don't have one or don't have the information necessarily to weigh in. But I certainly know of this just as kind of like a citizen and human being who lives in Massachusetts. And I guess what I will say, of course, though, is that any major change, any major built structure should go through a full process in terms of thinking about ecological impacts. And so, that's a critical piece. But in terms of me personally and what I know of, I haven't even, I don't know enough about that process to even know where the information falls one way or the other. So unfortunately, I'm not a good expert to give you input on that. I see this question from Anita that came in a couple minutes earlier. I heard or read somewhere that about half the oxygen in the air comes from plants on land, about half from plants in the ocean. Will warming the ocean have an affect oxygen levels? That is generally true. We don't really know. Most of the oxygen that's coming out of the ocean is from these very small single-celled bacteria that are producing a lot of it. And they tend to live out in the open ocean. And I'm not sure what the consensus is on the extent to which they will be affected by warming and their ability to photosynthesize and produce oxygen. But that's a great question that I'm going to go look up after this.
And perhaps you could share with us, when you have time to look that up, you could share with us what you find, and we could send it out to everyone that registered.
Yeah, I'd be happy to. I mean, fun story about those critters. They're what's called a cyanobacteria, and they're two genera, two genus, called Synechococcus and Prochlorococcus, and they are massive producers of oxygen. And we didn't even know they existed until I think it was the 70s or 80s, because they were so small and we hadn't even really looked, nor did we have the microscopes to look very well. And so it's sort of amazing to realize that we think we figured things out, you know, a long time ago, but we didn't even know that this one of the largest sources of oxygen on the planet existed until, you know, 40, 50 years ago. So pretty cool.
Colin, would you like to ask a question here?
Sure, I can ask a question. One question, this is more of a personal thing, but I was curious about how you got involved in sort of marine biology, marine biology research. I don't know if that's something that you want to speak about, but I'm always curious about how people get into, you know, specific climate work or specific research they're doing. So yeah, I was just curious about how that began for you and what sort of carried you through that, what's been motivating and sort of interesting about it for you personally.
Sure, yeah, happy to talk about it. I got interested in just bodies of water growing up in Vermont and doing a lot of fishing. I fished a lot in Vermont and I fished a lot in Michigan with my grandfather. And where I was fishing was in northern Vermont on Lake Champlain, which I came to learn at a pretty young age was a part of the world that was being pretty impacted by humans. And specifically, we'd see these massive blooms of cyanobacteria, again, like Cyanobacteria and Prochlorococcus, but different kinds that live in freshwater, that would basically turn the entire lake split pea soup green. Like it would just cover it. And when that happened, we couldn't go swimming. And the reason we couldn't go swimming is because they created yucky stuff that I didn't really know much about then, but I do now, which is it produces neurotoxins. These neurotoxins can be so bad that they would lead, if they were ingested, they would actually kill people's dogs, for example. So they're really bad stuff. And the reason for that is largely related to the runoff of nutrients, runoff of fertilizer and runoff of manure from farms around the lake. And so I was able to see sort of firsthand and be impacted firsthand by how humans were impacting an aquatic ecosystem, and it was negatively impacting me. And so when I went on to undergrad at the University of Vermont, which is also in Lake Champlain in Burlington, I got interested in that some more, started studying it. And then from there, I was sort of hooked on doing like aquatic water-based research. Tried out some sea turtle research in Mexico, which was incredibly fun and interesting, and did a few other things before going on to Scripps and then finding coral reefs. And so for me, it was sort of born out of really liking to spend time on waters and on the oceans, but also having these moments where I was kind of like, whoa, this is a very negative impact that I'm seeing on this ecosystem, and it's due to what humans are doing. Because even as a kid, I could still comprehend, like, manure runs off into the lake, it causes this green stuff to grow, that's bad for us, you know? So it was pretty clear. And so that was kind of my inspiration from early on.
Thank you for that, Dr. Hartmann.
Sure.
Well, maybe we'll transition here briefly to share about how climate change is impacting Homo sapiens here. So what we'll do is I will share a slide here. I will share a slide and show you all how we are impacted. And we won't take too much time. And then we have we can also ask some additional questions if necessary, if you think of any questions for Dr. Hartmann. But want to just show you very briefly what we at Crew do in light of the changing climate. So I'm going to share with you all a PowerPoint here, and can you all see this here? All right. So thank you, Dr. Hartmann, for articulating how climate change is impacting coral reefs. And someone may be wondering, well, what's the impact on Homo sapiens? What's the impact on humans? And we're really so glad you asked. But before we delve into that, for those who don't know, just wanted to share the mission statement with you all. That CREW is a young grassroots organization that aims to build equitable, inclusive neighborhood climate resilience in New England through hands-on education, service, and planning. We hold workshops throughout the year, virtual now since the inception of the pandemic. We've been blessed to be able to provide energy efficient AC units to low income residents in Brockton, Massachusetts for the summer of 2020. And also this past summer, we've been able to give out heat kits, cooling kits, we call them, really designed for people that have to go out in temperatures over 90 degrees. And there are things in those kits such as electrolytes, water, thermometer, cohesive wrap to be able to address heat exhaustion and heat stroke. So we've been able to do several things in that capacity, and we're really so glad about it. Just wanted to share with you that, extreme weather, when we talk about extreme weather, we're talking about floods, lightning, tornadoes, hurricanes, heat waves, winter, cold, wind, etc. And we know that these things are brought on because climate change has been happening since the Industrial Revolution. In fact, the last 150 years, there's a correlation between the amount of methane and gas and coal, the burning of coals in the air, and the global temperature rising up at a rate never seen before. So we see here a 30-year average, according to the National Weather Service, of 138 people dying per year from 1991 to 2020. That's atrocious. And we see many other different things such as, and this is per year, folks. We see many other different things such as hurricanes that kill on average 46 people a year. And this is across America, by the way, limited to North America. So there are a few different type of impacts that we expect to see here in New England. One is heat waves. This is a chart of, on average, the hot days that we've seen in the past, the hot days that we're expected to see in the future. And obviously, climate change, there's a lot of tipping points. So, at the unchecked level, we would be seeing over 31 hot days, temperature over 90 degrees in Boston, in the greater Boston area, in New England, and certainly parts of southern New England. And we see here from 2055 to 2084 that there will be over 60 days of extreme heat. And we know that summer here in New England is considered 91 days from June through August. So you're talking about a sweltering hot summer if we don't mitigate the climate crisis. But even yet and still, we would have decades of extreme heat that we would be dealing with because the climate has been changing. So that's one particular impact that we see here in the New England area. Another impact is stormwater runoff. So I just took the example of the city of Cambridge. So we see here about 2770 between Central and where MIT is, that this is going to flood extensively. And this is just stormwater flooding. So we see that this is real. And we know, according to the National Climate Assessment, that climate change brings more rain and more snow, or I like to say climate chaos, because sometimes when people think about climate change, they just think about hotter days and not necessarily the increased precipitation that comes. So here, 1958 to 2016, the top 1% of storms that hit New England, and this is, as you can see, this is all over the country, increased by 55% of precipitation. So the top 1% of the biggest storms that have hit throughout that time frame have increased by 55 inches of rain and snow. And again, you can see other parts of the country there. We know that coastal flooding is going to happen. You know, this is Boston by 2030, Boston Commons right there. This is Boston by 2050. As you can see, more and more areas are beginning to become flooded. And then we see Boston by 2070 if climate change is unchecked and if we don't slow it down, if we don't stop burning fossil fuels, coal, and gas and turn to clean energy, climate change left unchecked will look like this. And certain neighborhoods in Boston will be underwater. And this is threat. And we know cities like Miami will completely be underwater, which is already at sea level. So this is a third impact. So we said heat, stormwater runoff, coastal flooding, and hurricane surges. So we're likely to see more hurricanes. We know that Hurricane Ida killed a bevy of people and down south and Pennsylvania, New Jersey, New York. Hurricane Sandy would have hit Boston at a deeper and had a deeper impact if it had hit us 5 hours earlier at high tide. So we're expected to see more hurricanes. So there's a lot of social and psychological impacts, such as people suffer PSTD. 1 in 6 people have developed PSTD. 54% of adults and children suffer depression after a natural disaster. And we see that 49% of Hurricane Katrina survivors developed an anxiety or mood disorder. And there's a lot of psychological consequences because of that. And if we had a psychologist on the line the other night, one of our events, and he goes into that. So feel free to check that out. And there's also a thing called nostalgia, and we're almost done here. Nostalgia is the loss of sense of place, solace and security tied to one's physical environment. So that's a 50-cent word of saying that a person feels lost when a climate event happens and disrupts their whole life and their livelihood. But antithetical to that, we see cooperation, establish social ties and connections within community members. This helps withstand changes and encourage adaptation. So what we realize, folks, is that the greatest way to become climate resilient is through social resiliency. And there was a study done in Chicago where 739 people died because of a 5-day heat wave. It was proven by Eric Klingenberg, who's the author of the book. He said, it's called Heat Wave, that's the name of the book. And there's also a movie that came out a couple years ago. It said people that didn't die, like the greatest indicator of survivability during extreme weather is social connectivity. And that's what we're about at Crew and what we do. So what does Crew do with all this? We have community teams. We're looking to continue to develop community teams. We have a solid one in Somerville, and community team. You know, the pandemic has certainly impacted that, the preventing of people coming together and make it more risky for people to come together. But we are in the process of working with several different communities to help launch a Crew team. And this is a team that folks are interested in getting to know each other, have time to come together at least once a month. And our teams in Somerville have done climate socials, and they have done deep having, things of that nature. We also have hubs, Climate Resiliency Hub. Colin, and I didn't properly introduce him, so forgive me. He is our Climate Resilience Coordinator, and we are excited about the work that he's embarking on. He's been with us for several weeks now, but he's the coordinator of this particular part of the Crew program. And we have 70 hubs across the country. Level 1, level 2, level 3, and we'll include that in an email. We'll send a link to that so you can learn more about the levels. It's on our website, but simply put level 1 hubs, which most of our hubs are essentially, virtually all of them are, but some are interested in moving to level 2. And again, we'll talk about that in a follow-up email that we send you all, the various levels, in case you are affiliated with a community organization, a faith community. A lot of our hubs are libraries, mosques, churches, synagogues, other type faith gatherings, community organizations. And really the criteria is for an organization to become a hub is for an organization that's meeting some type of social, economical, or physical need within a community. And again, we can talk more offline about that. But level 1 hubs are those that display a resiliency hub, decal, like the one you see here. They make emergency climate preparedness information available, ready to be available, and crew provides that. And they agree to host one-year events. And really the purpose is for people to have a safe place in the community. Again, we'll talk more about that. So we want to thank you. And we can't forget our wonderful intern, Allie, from Tufts University. She's also helping us. But that's a little bit about what we do, because at the end of the day, we want our crew, we envision crew teams for people to be doing wellness checks during extreme weather events. And I'm going to stop sharing my screen. Let's see here. All right. Yeah, so we want people to, of our team to connect with neighbors who are most vulnerable. So that's a little bit about what we do. So I'm going to put a pin on it to see if there's any more questions for Dr. Aaron, or questions about what we do at Crew, or there are any final thoughts that Dr. Hartmann would like to share. But we can give it a second if people have questions, because we want to be respectful of folks' time, and we'll even give you some time back. We're expected to end at 7, and we may give you some time back depending on if there's any more questions. And if there's not any more questions, then I will ask Dr. Aaron to share what final thoughts.
Sure, yeah.
People can get in contact with you, and if we can share your contact information when we send the email out, if that's okay.
Yeah, absolutely. I was going to say I should hop off myself, but I just want to thank everyone for being here tonight. This was really fun. Great to chat with all of you. And thanks, Reverend Walker, for sharing that work. Vernon, it's fantastic to hear. And I'm very excited to watch those other events. So please let me know when those are posted. Hope it was informative, and hope you all enjoyed it tonight. Absolutely feel free to share my contact info. People can absolutely reach out with any questions you have or thoughts or whatever. So yeah, I guess with that, I'll sign this off, and then I'll hand it back to you. But great to see all of you tonight, and thank you all for being here.
Well, thank you, and thank you all for being here. We'll get this video shared out. Thank you, Dr. Hartmann, for taking some time out. Thank you all for being here, and we will be in touch. Thank you, Facebook audience, for seeing this, and we will catch you. We will be in touch soon. Thank you.
Great. Sounds good. Thanks, Vernon. Thanks, Colin. Take care.